Hello and welcome to this video solution of chapter 7. So what I'm going to do is show you what I was looking for, and then hopefully you'll look at the error codes and the descriptions and make sure that you've got the same thing and that you understand why you were counted off. So in problem 2 and all of these, you were supposed to do a scatter chart, and then I wanted you to tell me what was the relationship of the chart. That is, whether it was a negative relationship or a positive relationship. So for problem 2, we've got the scatter chart here. This is a negative linear relationship. Some of you just threw up the scatter chart and didn't say a word, and you're letting the reader assume what it is. They could assume incorrectly. I don't know that you know whether it's positive or negative, and so that's why you've got counted off. Then you're supposed to do the regression analysis, and so I was looking for something like this. It's not enough just to throw some numbers up on the screen. I was looking for, could you actually write out the regression equation? That is, using the intercept, that's where this value came from, minus this value, and then you need to say times x here because that goes with that independent variable. And if you left the x off, I took off points for that as well. For part C, you could check and see if some different conditions exist for valid inference of regression. One is to plot your residuals. You would see something like that. They are equally, not equally, but kind of distributed around 0, and so it doesn't provide any strong evidence of a violation of the conditions, so you would proceed with your inference. What I'm looking for is we do not reject a hypothesis of beta 1. Beta 1 is this value right here. Notice that the p-value, when this was run, is 0.02. If we're looking at the 1% level of significance, 0.02 is not less than 0.01. So that's the reason why you do not reject. So that's what I was looking for. Then it wanted to know the coefficient of determination, or R squared, and that was this value, and you get that value from this area right here. And so that's what I was looking for problem number 2. Problem number 3, similar way of going about it. Here's the scatter plot. That's a positive linear relationship. That is, as x increases, the y increases. Here's the output. Again, I wanted you to write this regression equation. Again, the coefficient should be here. This is the independent variable coefficient, or B1. This is B0. The intercept is B0. The R squared is 85.61. So for part C, it doesn't look like we violate any inference here, even though we've got 10 observations. Again, but this time we reject the hypothesis. And there were some other things that you could talk about, given that if we said B sub 0, and set B sub x equal to nothing, then what's the value here? So if we put the 0 in for x, and the value is this for y, and that doesn't quite make any sense. Now you could say that, but the main thing I want you to understand is that p-value is less than the 0.05 level. So again, if we're looking here, here's the p-value, that's less than 0.05, same thing for B0. The first problem 2 is looking at the 0.01 level. This one's at the 0.05 level, so you would reject. Then there was a part E that says, okay, if you had, I believe it was break-even hours or weekly usage for the proposed $3,000 contract. I wanted you to go ahead and determine what that value of that contract would be for the average number of hours. And yes, that's less than what it would be expected, and so then you would go ahead and purchase. And I even gave this example and put it up as a video on the website. And I don't think very many people, maybe one or two of you, even looked at it or made use of it. So I'm not sure what's going on. You're not coming back to the website and paying attention. For problem 4, scatter plot again. This is a negative linear relationship. As x increases, the y's come down. You got your regression output. I'm looking for the equation again. The equation comes from B0, B1. And put the x out to the side. We check and see if there's any problems with our inference. Since we don't have 30 observations, we just have 10. Again, with B1, we reject the hypothesis. With part D, B0, we again look at that p-value for B0 here. That'd be 8.4 to the 10 to the minus 6th. So we would reject again, but does that make sense? And that is, we would say that probably doesn't make sense. So again, I'm just looking to see if you really understood whether you rejected or not. The coefficient determination is 71.09%. We get that from right here, this line. All right, so that's what I was looking for in problem 4. In problem 7, we do a scatter chart. Again, this is a positive linear relationship. Wanted to make sure you knew that. We got the regression output. I want to know that you can write that equation. Again, B0, B1. So it's always B0 plus B1 times X. If this happens to be negative, then you would just make it a subtraction line. This B1, that is. But here it's positive. See, are we accepting or rejecting our analysis? We check and see if we violated any conditions for regression here, since we don't have a lot of observations and we don't see any violations, so we proceed. B1, we reject the hypothesis that B1 equals 0, and we see the p-value is a very small number, and it doesn't go through 0 for upper and lower 95% or even a 99% confidence level. So we reject. For B0, again, we would probably say you can reject, but you can also say that it was meaningless because the y-intercept has been estimated through the extrapolation. The coefficient determination is 94.86%, so it explains a lot. For part F, we want to find out what is the predicted S&P value. It's 1,454 points. If we put in 13,000 here, and I should say that that value here should be 13,500. So the value listed here is what I would be looking for, is what you got. Then for part G, did you understand that the value you're looking for, 13,500, it's beyond the range of the DJIA, Dow Jones Industrial Average, used to develop the regression model. So I wanted you to be able to notice that it's outside of the bounds of your regression model, and it's probably not going to be good to go outside of that and extrapolate it. All right, for problem 8, we again do a scatter plot. This looks negative. So I'm looking for a negative linear relationship. As x increases, y comes down. Then you have the following regression output again. Again, you got r squared here. 53.86% of the variance is being explained by this independent variable miles. The B1 coefficient is a negative 0.058. And then you have the B0, or the intercept, is 16.46. So I'm looking for you to come up with a model that looks like this, your equation. Again, here it's negative because it's negative here, and always have the x out to the side. We want to see if we violated any conditions for our regression inference. Again, it looks sort of normally distributed or equally distributed, and so we'll proceed. B1 you would reject. So B1 here is here. It's very small. Both of those are very small at the 0.05 level. And so you would conclude that there is a relationship between miles and price. Same thing for B, that's B1, and then same thing for B0 you would reject. But again, you could also say it's meaningless because the y-intercept has been estimated through the extrapolation, meaning that if you put 0 onto this equation here, that is miles it's never been driven, then the car is 16,498. We saw what the coefficient of determination is. Part E, you would do the residuals, and the highest residuals, negative residuals, would indicate where the cheapest car was, and that would be right here on number 4 and number 12. So I was looking at some indication of those two cars. The 4th and 12th model is the best one, and then the 4th one. And then the last one is, what would you pay for a car with 60,000 miles on it using that equation above? So I wanted you to understand what you needed to do in order to plug the 60 into X. Remember, X represents miles on the car. So we do 60,000 miles here. And remember, when you created this, the miles were in thousands. So that's the reason why you would only use 60 right here, because that's already 60,000. Plug that in, your car would be $12,943. So it would be a reasonable price to expect to pay. So that's the solutions to this first part of Chapter 7.